All right, this topic is about solving linear inequalities. And honestly, you do that almost exactly like solving linear equations. The thing that makes them different is something as we go along solving them. I'll show you there's a little trick that we need to remember. And the reason why they look different is because we have symbols like this. We have a less than sign. And if you don't know these, please make sure you write them down because they're important to know. This is your less than or equal to. And again, they may not feel super important for this topic even after you're done with this topic, but there's a lot more inequality stuff coming up, graphing them and such things where you're going to need to know which is which because it's going to depend on what you do. Then we have a greater than sign. Of course, if we have a less than or equal to, we also have to have a greater than or equal to. All right, and again, make sure they're somewhere in your notebook, tabbed or something, so that you can find them again when we hit the graphing pieces and stuff like that. All right, solving linear inequalities. They feel a lot like solving equations. Let's see. Let's start with an example. We'll just keep it easy. Negative 4u plus 16, here comes the inequality, is greater than or equal or greater than negative 24. All right, so if there had been an equal sign instead of a greater than sign, just think about what you would normally do. It would look like your basic two-step algebra problem. So we'd get rid of the 16 by undoing the addition, just like normal. Again, you want to rewrite negative 4u is greater than, what is negative 24 minus 16? That's going to give us negative 40. Again, I would ask you the question, what would you do normally to solve this for u? You divide by negative 4. Same exact steps. Here's the key though. When you divide both sides of an inequality by a negative number, you need to flip the inequality sign right after that. So we've divided both sides by a negative 4. Excuse me. So we're going to write our answer as u, and instead of it being greater than, we got to flip it, and it's now less than. And then negative 40 divided by negative 4 is 10. That is our answer for that problem. Towards the end of the video, I'll explain why we have to do that flip. If you don't care to listen, you can just hit stop and not listen to it, and that's absolutely fine. That won't hurt my feelings at all. All right, let's try another example just so that you don't think I'm just pulling the wool over your eyes and that, yes, indeed, it is that easy. So let's do 9 is less than 21 minus 2y. All right, again, how would you normally solve it to get the y by itself? You'd get rid of the 21. So let's subtract the 21 from both sides. 9 take away 21, that's going to give us a negative 12. Keep our less than sign. Oh, and don't forget that negative sign is married to that 2. And here we go, same deal. We're going to divide through by what? By a negative number. So when we divide through by a negative number, we need to flip it so it's now greater than. Those guys cancel out, and negative 12 divided by negative 2 is positive 6. All right, so we need to write that rule down in our notes before we forget. So when you divide, and actually the same is true for multiplying, or multiply both sides by a negative number, flip the inequality. That is really like the biggest thing to remember in this. Other than that, it should feel like I'm not really learning anything. This feels like stuff I've already learned, except for that one trick. All right, let's do one more example. I'll show you a part where we multiply on both sides. Let me just slide this guy up a little bit. Okay, let's see, pen. All right, so let's say that we have, this might not come out very pretty, but if we have 3x over negative 7 equals 10. Oh, sorry, I don't want to use equals, right? That would just be an equation. Let's use greater than or equal to. All right, so how do we get the x by itself? Well, as always, if we have a fraction, we like revel in the fact that we despise fractions and we say, hey, I'm going to kick that fraction out of there. And how do we do that? Get rid of this negative 7. The negative 7 is dividing, so how do we undo division? We multiply. So we're going to multiply both sides by negative 7. And here it cancels out. We rewrite. Now we multiplied both sides by a negative 7. So we need to flip it. And then 10 times negative 7 is negative 70. And then the last step, we need to divide by 3. Now the 3 is positive. We don't need to worry about flipping it, only if we are using a negative number. And I'm going to keep that as an improper fraction because that's generally what we do in algebra. And there you go. So that's another example. I'm going to give you a problem in a minute that you can try on your own. Let me just pause this. All right, so for this example, why don't you write it down, hit pause, and then try solving it on your own, and then hit play and see if you get the same answer that I get. All right, so negative 14 minus 5y is greater than or equal to negative 4. All right, hit that pause button. All right, let's see if you did it the same way that I'm going to do it. I'm going to start by adding a 14. And that negative sign is married to the 5. You can't do anything about it. I'm not going to flip yet. Negative 4 plus 14 is going to give me positive 10. Now to solve for y, I'm going to divide both sides by a negative 5. And I need to remember, dividing by a negative, I got to flip it. Alright, so now I'm going to have y is less than or equal to 10 divided by a negative 5. It's going to be a negative 2. Alright, how's that? Alright, cool. So if you want to know how to, why we have to flip this thing, I will explain that now. Alright, so we're just going to make, this won't have any algebra, this explanation. Let's just say that we have, I don't know, 10. And we're going to say that that is greater than 4. And that's a true statement, right? 10 is greater than 4. So what we're going to do is we're going to do a bunch of different operations on the 10 and the 4. And for each operation, we're going to see that we're going to decide if we have a true statement after it. So for the 10 and the 4, let's say that we're going to add 3 to both of them. So 10 plus 3 gives us 13. And 4 plus 3 gives us 7. Is 13 still greater than 7? Yes. So we added a number. And it was still a true statement. 13 is still greater than 7. Let's try subtracting, I don't know, 2. 10 take away 2, that's going to be 8. 4 take away 2, that's going to be 2. Is 8 greater than 2? Yes. So far we've added a number and we subtracted a number and we still end up with true statements. Alright, let's multiply both of them by 4. 10 times 4 gives us 40. 4 times 4 gives us 16. Is 40 still greater than 16? Yes. Cool. Now let's try dividing them both by 2. What is 10 divided by 2? That's going to give us 5. 4 divided by 2 is going to give us 2. Is 5 greater than 2? Yes. So we've added a number, subtracted a number, multiplied by a positive, divided by a positive number, and every single answer after we've done that has remained true. We still get true statements. All of the answers are still greater than the other answers. Now here's the tricky part. Let's say we're going to multiply by negative 3. 10 times negative 3 is negative 30, and 4 times negative 3 is negative 12. Is negative 30 greater than negative 12? No, siree, it is not. So what we have to do to make this a true statement is we would have to change the inequality and flip it around, because negative 30 is less than negative 12. That would be making it a true statement. And again, let's see what happens if we divide by a negative number. 10 divided by negative 2 is negative 5, and 4 divided by negative 2 is negative 2. Is negative 5 greater than negative 2? Negative 5 is much further down the line than negative 2 is, in the negative direction. So this is also false, and the only way to make it a correct statement is, again, to flip that inequality. Negative 5 is less than negative 2. So that's the main, easiest way to explain why do we flip the inequalities for negative numbers when we multiply by them and divide by them. And that's the reason, is because we're doing something to those numbers that is going to cause something to be false. So to make it be illegal or a true statement, you need to flip the inequalities, and then you're being okay. So, all right, I hope that helped a little bit, and good luck.